Welcome back, everyone! Today, we are going to continue exploring our fundamental calculus limits by deriving the derivative of the standard cosine function, y equals cosine of x, from first principles. Let's break down the math step by step. We begin with our baseline function. Let y equal cosine of x, which we will call equation 1. Next, let's introduce small increments to our variables. If x changes by a small amount, delta x, then y will shift by a corresponding small change, delta y. This gives us our second equation. Y plus delta y equals cosine of x plus delta x. Now let's isolate our change in y by subtracting equation 1 from equation 2. This yields delta y equals cosine of x plus delta x minus cosine of x. To turn this difference into a product, we apply the standard difference of cosines trigonometric identity. Simplifying the angles carefully gives us 2 sine of 2x plus delta x over 2 times sine minus delta x over 2. To change this expression into a rate of change, we divide both sides by our independent variable increment, delta x. This prepares our expression for the limit process. Let's apply the limit. As delta x approaches 0 to both sides, the left side resolves into our standard derivative notation, d over dx of y. On the right side, we separate our limits to isolate the special fraction. We manipulate the terms to align with our standard limit theorem, where the limit of sine of x over x, as x goes to 0, is equal to 1. Evaluating our limits, because we have a negative increment inside the angle, that special sine limit evaluates to -1. Meanwhile, substituting 0 for delta x simplifies the remaining sine term directly to sine of x. Multiplying them out gives us our final result. The derivative of cosine of x with respect to x is exactly negative sine of x. Thank you so much for watching. If this step-by-step breakdown made finding trigonometric derivatives from first principles clear, please hit that like button, subscribe, and share. See you next time.